Alright, continuing chapter 7. Um, alright, non-ferrous metals, aluminum. General aluminum is lightweight, soft, with a low-strength metal with which could easily cast forward, machine, formed, welded. It is suitable only with a low-temperature application, except for the alloy-specific elements. Copper and aluminum alloys are classified in two groups, which are raw alloys and cast alloys. Raw alloys are groups include alloys that are designed for mill products with the final physical forms obtained working with metal mechanically. Cast alloy groups are included with the alloys with the final shape obtained with alloying the molten metal to solidify in a mold. Use aluminum as either the deoxide or aluminum agent in the manufacture of steel, casting pistons, torque converters, pump housings, aircraft structures, kitchen utensils, rail cars. Transmission lines are made of aluminum. Capabilities: aluminum can be cast, forged, machined, or formed or welded. Limitations: direct metal contact aluminum with the copper. The copper alloy should be avoided. Aluminum should use the low temperature applications. Property for the pure aluminum with a brittle test number of 17 to 27, the tensile strength of 6,000, 16,000 psi, the specific gravity of 2.7, the melting point of 1220 degrees. Aluminum alloys, a brittle hardness test of 100 to 130, tensile strength 30,000 to 75,000 pounds, high heat conductivity. General aluminum and aluminum alloys have excellent heat conductivity, high electrical conductivity, 6% of the copper volume. Of copper volume of their volume, high strength, weight rate at a room temperature, unfairly corrosion resistant. Appearance: aluminum is light gray, similar in color, vary with the bright, with the polish and dull, with oxide, light in weight, gold and steel. Aluminum material, usually pure metal. Casting with aluminum alloys with the other materials using zinc, copper, silicone, sometimes iron with a magnesium. Raw alloy steels may contain chromium, silicone, magnesium, manganese. Aluminum strongly resembles magnesium in appearance. Aluminum is distinguished from magnesium by application of a drop of silver nitrate solution on each surface. Silver nitrate will react to the aluminum but leaves black deposits of silver over the magnesium. Your fractures test: the fractures rolled aluminum section shows a smooth, bright structure. Fracture aluminum casting shining with a bright crystalline structure. Spark test: no sparks are given off from aluminum. Torch test: aluminum does not turn red before melting. It holds its shape until almost molten, then collapses hot, short, suddenly. Heavy film of the white oxide forms instantly on the molten surface. Alright, chromium. General chromium is an alloying agent used in steel, cast iron, and non-ferrous alloy with nickel, copper, aluminum, cobalt. With the hard, with the brightness, corrosion resistant, can be welded with machine forged. Is widely used with electroplating. Chromium is not resistant with hydrochloric acid and can be used in pure state because it is difficult to work. We use the chromium is one of the most widely used alloys. It's used with an alloying agent in steel and cast iron of 0.25 to 0.35%. In non-ferrous alloys, nickel and copper, aluminum, cobalt is also used with the electroplating appearance with the wear with the power of metallurgy and to make mirrors in stainless steel. Capabilities: chromium alloys can be welded with the machine. With the forged chromium is never used in pure state. Limitations: chromium is not resistant with the hydrochloric acid and can not be used in pure state because of the brittleness and difficult to work with. Properties: pure chromium has a specific gravity of 7.19, melting point of 3,300 degrees Fahrenheit, brittleness hardness number of 110 to 170, resistant to acids other than hydrochloric, and its wear and high heat and corrosion resistant. Cobalt: generally, cobalt is a hard white metal similar to the nickel appearance, but has a slightly bluish color. Bluish cast. Usually cobalt mainly used with the alloying element with a permanent soft magnetic metals, high speed tools, bits, cutters, high temperature creeping, resistant alloys, cemented carbide tools, brits, cutters, and also used in making the insoluble paint and pigments and blue ceramic glazes. In the metallic form, cobalt does not have many uses. However, combined with other elements, is used with a hard facing material. Capability: cobalt can be welded, machine limited, and cold drawn. Limitation: cobalt may be machined with ceramic carbide cutters. Welding high carbon cobalt steel is often causes cracks. Properties: pure cobalt is a tensile strength of 34,000 psi with a brittle hardness of 125, specific gravity 8.9, melting point of 220. 720 degrees Fahrenheit. Cobalt alloy or stellite 21 has a tensile strength of 101,000 psi and is heat corrosion resistant. Your copper. General copper is reddish metal with a very ductive malleability with a high electrical heat conductivity used with a major element and with 100 alloys. Commercial pure copper is not suitable for the welding too. They are very soft and very difficult to machine due to the high ductility. The barium copper contains 1.5 to 2.75% barium and is ductile when the soft lost to the Lost ductility, gains tensile strength when hardened. Nickel copper contains 10 to 20 to 30% nickel. Nickel alloys moderate high to high tensile strength that increase the nickel content with a moderately hard, quite tough, and difficult, very resistant, erosive, and corrosive to the effects of the high velocity seawater, stress, corrosion, fatigue. Nickel is added to the copper zinc alloys. Brass is to lighten their color. The resultant alloy is called nickel silver. The alloys of the two general type of the one type with the 65% more copper than nickel and nickel combined. Other containing 55 to 60% copper and nickel combined. First type can be cold work. First type can be cold work by such operations as deep drawn, stamping, and spinning. Second type is harder and is not processed by any cold working methods. Gas welding is the preferred process for the joining copper and copper alloys. Use. The principal use of the commercial pure copper is in the electrical industry, with made with wire with the other such conductors. It is also used to manufacture non-ferrous alloys, brass, bronze, vinyl, metal. Typical copper product is roofing, cartridges, cases, bushing, wire bearings, and statues. Copper capabilities. Copper is a can be forged, cast, cold worked, and it can also be welded with a machining ability only fair. Copper alloys can be welded. Limitations: electrolytic, tough pitch copper can be made satisfactory. Pure copper is not suitable for the welding, difficult to machine due to its ductility. Properties: pure copper is non-magnetic, brittle, hardness with a number than 60 to 110, and tensile strength 32,000 to 60,000 psi to 413 and 413,700 and specific gravity, 32,000 to 60,000 psi, specific gravity 8.9, melting point 1980 degrees, and corrosion resistant copper alloys have the tensile strength of 50,000 to 90,000 psi and a brittle hardness of 100 to 185. Appearance testing: copper is red in color, polish and oxidization is very shades of green. Fracture test: copper presents smooth surface for when fracture is free of crystalline appearance. Spark test: copper gives off no sparks. Torch test: because copper conducts a high, rapidly large flame with the required to produce the fusion with the copper with the need for the same size piece for the steel. Copper metal suddenly solidifies instantly with the copper alloy containing a small amount of the other metals may be used easily, solidifying more than slowly than pure copper. Alright, brass and bronze. Brass alloy copper, zinc 60 to 68% copper, 32 to 40% zinc, low melting point, high heat. Conductivity: several types of brass, such as naval red, admiralty, yellow, and commercial. All different copper and zinc content may be alloyed with other elements such as lead, tin, magnesium, iron, or have good machinability and can be welded. Bronze is an alloy copper, tin, and may contain lead, zinc, magnesium, phosphorus, and high strength and non-rust corrosion resistant. Has good machinability, can be welded. Art appearance: the color of the polished brass with the bronze varies with the composition. Red, almost like copper, and yellow brass oxidized various shades of green, brown, and yellow. Fracture structure: surface of the fractured brass with bronze ranging from smooth crystalline depending on the composition, method of preparation of the cast, rolled, or forged. Spark testing: brass and bronze gives off no sparks. Torch test: brass contains zinc, in which gives off the white fumes when it's melted. Bronze contains tin. Even the slight amount of the tin makes the alloy flow very freely like water. Too small amount of zinc to tin is usually present in bronze, maybe fume slightly, but never as much as the brass. Alright, aluminum bronze appearance test. When polished aluminum bronze appears with a dark yellow than brass. The fracture test: aluminum bronze presents smooth surface with fractured. Spark test: aluminum bronze gives off no sparks. Torch test: welding a bronze is very difficult with a surface quickly covered with a heavy stone with the tins of the mixing with the metals is difficult to remove. Alright, lead. Caution: lead dust fumes are poisonous. Extremely care with when welding lead. Personal protective equipment is described in Chapter 2. General: lead is heavy, soft, malleable metal with low melting point, low tensile strength, low creep strength. It's resistant to corrosion from ordering atmosphere, moisture, and water. It is effective against many acids. Lead is well suited for the color welding, casting. Low melting point of lead makes correct welding rod selection very important. Uses: lead is mainly manufactured electrical equipment such as lead-coated power, telephone cables, and storage batteries. Also used for the building construction pipe, the sheet form, and solder. Zinc alloys used to manufacture lead weight bearings, gasket seals, bullets, and shots. In short, many types of the chemical compounds produce lead. Among these are less carbonate, paint, and pigment from the tetraethyl anti-knock gasoline. Lead is also X-ray protection. Radiation shields. Lead has more field for application than any other metal. Capabilities: leads can be cast, cold work, welded, machine corrosion, atmosphere moisture, water resistant, is resistant to most acids. Limitation: lead has low strength and heavy weight. Lead, dust, and fumes are very poisonous. Properties: pure lead has a tensile strength of 2,500 to 3,000 psi, specific gravity 11.3, a melting point of 620 degrees Fahrenheit. Alloy lead B32467, tensile strength of 5,800 psi. Generally, lead has a low electrical conductivity, self-lubricating, malleable, and is corrosion resistant. All right, magnesium. General. Magnesium is extremely light metal with a color with a low melting point. With excellent machinability, is weldable. Welding by either arc or gas process requires the use of gas shield. Magnesium is a moderate resistant atmospheric exposure chemicals such as alkalized chemicals, chromatic, hydrofluoric acid, hydrocarbons, most alcohols, phenols, esters, and oils. Its non-magnetic solvent corrosion is an important factor in even the assembly of the magnesium. Uses magnesium to use the deoxides of brass, bronze, nickel, and silver because of the lightweight. It is used for the many weight-saving applications, particularly with the aircraft industry. It also used the manufacture use of fireworks for the railroad flares, signals, and for military purposes. Magnesium casting are used for engine housing, blowers, hose pieces, lading wheels, certain parts of the fuselage of the aircraft. Magnesium alloy materials are used in sewing machine, typewriters, and textile machines. Capability: magnesium can be forged, casted, welded, and machined. Magnesium fine chip from ignite with a low temperature of 800 to 1200 degrees Fahrenheit. The flame can be smothered with a suitable material such as carbon dioxide, foam, and sand. Properties: pure magnesium has a tensile strength of 12,000 psi, a tensile strength of 37,000 psi, and a brittle hardness number of 30, and specific gravity of 1.7, a melting point of 1,202 degrees. Magnesium alloy, brittle hardness number of 7250, forged, and tensile strength 42,000 psi. Alright, your appearance test. Magnesium resembles aluminum in appearance with the polished surface with a silver white, but quickly oxide with a grayish film, like of aluminum, high corrosion resistant, good strength of weight ratio, but is lighter than weight of aluminum, very low kindle point, and is not very weldable except for the alloyed magnesium and alloy. Magnesium and aluminum. Magnesium is distinguished from aluminum by use of silver nitrate solution. The solution does not react with aluminum, but leaves a dark deposit on silver on magnesium. Magnesium is produced in large quantities from seawater. It uses excellent machinability, but special care must be used when machining because of the low kindle point. Fracture test. Magnesium has a rough surface of fine grade. Spark test. No sparks are given off. Caution. Magnesium may ignite and burn heated in an open atmosphere. Torch test. Magnesium oxidize rapidly when heated with open air, producing oxide film with the insoluble liquid metal with the fire may result with the magnesium is heated in an open atmosphere. A safety precaution of magnesium should be melted in the atmosphere with inert gas. 7. Magnesium. General. Pure magnesium has a relatively high strength, but is very brittle. Magnesium uses an alloy agent and steel dioxide desulfurizes the metal. Metals other than steel percentage is 1 to 15%. Magnesium will increase the toughness and hardenability of the metal involved. Uses: magnesium is usually made an alloying agent making steel with an increase of the tensile strength with adding during the steel making process. Remove the sulfur from as the slag. Synthetic magnesium steel is used from railroad track work, power shovel buckets, rocks and crushers. Medium carbon magnesium steels are used to make car axles and gears. Capabilities: magnesium can be welded, machined, and cold work. Limitation: all synthetic magnesium steels are machined with cemented carbide, cobalt, and high-speed steel cutters. Your properties: pure magnesium has a tensile strength of 72,000 psi, brittle hardness of 330, strength, specific gravity of 7.43, melting point of 2,270 degrees Fahrenheit, and is brittle. Magnesium alloy has a tensile strength of 110,000 psi. General magnesium is higher than polishable and brittable. Alright, molybdenum. Pure molybdenum is high tensile strength with a resistant and to heat with the principle using alloy agent and steel with the increase of the strength with a hardenability resistant to heat. Uses: molybdenum is usually mainly as an alloy, heating element, switches, contact, thermocouplers, welding electrodes, cathode ray tubes, and are made of molybdenum. Capabilities: molybdenum is swag rolled drawn. Machine limitation: molybdenum can only be welded by atomic hydrogen arc or butt welded, resistant heating in the vacuum, attacked with a nitric acid and a hot sulfuric acid and a hot hydrochloric acid. Your properties are: pure molybdenum is a tensile strength of 100 psi, 100,000 psi, 30,000 and 30,000 psi wire. Brittle hardness number of 160 to 185, specific gravity at 10.2, melting point at 4,800 degrees, resistant hardness strength of all high temperature corrosion resistant. And 9 is nickel. Generally, nickel is a hard, malleable, ductile metal. As alloy will increase the ductility, no effect with the grain size lower, with a critical point of heat treatment. Acid aids of fatigue strength with increased impact value of low temperature operations. Both nickel and nickel alloys are machinable readily on welded gas arc methods. Usually, nickel is used for making alloys with both ferrous and non-ferrous chemical food processing elements, electrical resistant heating elements, ornamental trim, hearts over the which of the chain elevated temperature with all the produced with nickel containing metal. Alloyed chromium is used for the making of stainless steel. Capabilities: nickel alloys readily weldable by either gas or arc method. Nickel alloys can be machine forged, cast, or easily formed. Limitation: nickel oxide will very slowly in the presence of moisture or corrosive gas. Oxidize. Properties: pure nickel is a tensile strength of 46,000 psi, brittle hardness of 220, specific gravity 8.9, melting point of 2,650 Fahrenheit. Nickel alloys brittle hardness of 140 to 230. Mono forged nickel has a tensile strength of 100,000 psi and high strength toughness is at high temperature. Appearance: pure nickel is a grayish white color. Fracture: the fracture surface of nickel is smooth, fine grained. Spark test. Nickel produces a very small amount with a short orange spark and is very general wavy. Monometal is nickel alloy, silver white in color, containing 67% nickel with a 29 to 80% copper, 1.4% iron, 1.1% magnesium, 10% silicone, and a 1,500% carbon. And the appearance will resemble the untarnished nickel after the contact chemical solution. Silver white color. Takes yellow tinge, and some of the luster is lost. A very high resistance with the corrosion can be welded. Alright, your tin. Generally, tin is very soft and malleable, somewhat ductile, corrosion-resistant metal, having low tensile strength crystalline structure used for the coating of the metal to prevent corrosion. Used the major application for the coating steel is and serves in the best contained preserving perishable focal. Tin is the form of a foil, often used in the wrapping food products. Second major use of tin is in alloying element. Tin is an alloyed with copper to produce tin, brass, or bronze, with lead produced solder with antimony and lead to form babbitt. Capabilities: tin can be die cast, cold work, extruded, and machine soldered. Limitations: tin is not weldable. Pure tin has a tensile strength of 2,800 psi, specific gravity of 7.29, melting point of 450 degrees Fahrenheit, and corrosion resistant. Babbitt alloy tin has a tensile strength of 10,000 psi and has brittle hardness number of 30. Your appearance: tin is silver white in color. The fracture test: fracture surface of the tin is silvery white and fairly smooth. Spark test: tin gives off no sparks in a spark test. Torch test: tin melts at 450 degrees and will boil under the torch. Titanium: general titanium is very soft, silver white, medium strength metal, having very good resistance, high strength of weight with a ratio of tensile strength. Increases temperature, decreases. Titanium has low impact creep strength, as well as seizing tendencies as temperatures above 80 degrees Fahrenheit. Alright, uses. Titanium is a metal with a tin group with a curve with a natural with a tin oxide and other oxide forms. Free elements separated with the heating of the oxide of the aluminum electrolysis with the solution of the calcium chloride, and most important compound with the titanium dioxide, which is usually wide and welding electrode coatings. It uses to stabilize with the stainless steel so that the carbon can not be separated during the welding operation. Also uses an additive for alloying aluminum, copper, magnesium, steel, nickel, and making powder for fireworks. And in the manufacture of the turbine blades and aircraft firewalls, engine nacelles, frame assemblies, and ammunition tracks, and mortar base plates. Capabilities: titanium can be machined with a low speed, fast feeds, normal spot and seam welded, fusion welding using an inert gas. Limitation: titanium has low impact strength, low creep strength with a high temperature above 800 degrees Fahrenheit. It can only be cast into simple shapes and cannot be welded with the gas welding process because of the high attraction of the oxygen. Oxidization causes the metal to become quite brittle. The inert gas welding process recommended to reduce contamination of the welded metal properties. Pure titanium has a tensile strength of 100,000 psi. Brittle hardness test number 200, specific gravity 4.5, melting point 330 degrees, 330 3,300 degrees Fahrenheit, and good corrosion resistant titanium brittle hardness of the number 340, tensile strength of 150,000 psi, high strength of weight ratio, twice the aluminum alloy at 400 degrees Fahrenheit. Your appearance: titanium is very soft, shiny, silver white metal, burns in the air. The only element with the burns of the nitrogen. Titanium alloy looks like steel. It can be distinguished from steel by a copper sulfite solution. These solutions will not react with titanium, but will leave a coating of the copper on the steel. Spark test: the spark given off a large, brilliant white and medium length. Tungsten: general tungstens are hard, heavy, non-metallic metal, which will melt at approximately 6,150 degrees Fahrenheit. Tungsten is usually making light bulb filaments, phonograph needles, and any alloying agent. Production: high-speed steel, armor plate, projectiles. Is also used the alloying element agent. Non-consumable welded electrodes, armor plate, die, tool steel, hard metal, carbide, cutting steel. Capabilities: tungsten can be cold or hot drawn. Limitation: tungsten is hard to machine. Requires high temperature for melting. Produces powdered metallurgy, sintering, and process. Properties: tungsten has a melting point of 6,157 degrees plus or minus 35 degrees in Fahrenheit. Is ductile, has a tensile strength of 105,000 psi, a specific gravity 19.32, thermal conductivity 0.397, brittle hardness number 38, and is dull white in color. Alright, your appearance: tungsten is steel gray in color. Spark test: tungsten produces a very small volume of short, straight, organic orange streaks in a spark test. Alright, zinc. General zinc is a medium low strength metal with having very low metal with it is easily machined, having coarse grained zinc that should be heated with approximately 180 degrees Fahrenheit to avoid cleavage of the crystals. Zinc can be soldered over the welded, properly cleaned with a heat input with closely controlled. Uses: galvanized metal with the largest sheaf of zinc that is done with the dipping of the part of the molten zinc with electroplating. Example: the items made in this way with the galvanized pipe of the tubing, sheet metal with the wire nails, bolts. Zinc is used with the alloying element with the producing alloy with the stuff of the brass and bronze, but the alloys are made of the primarily zinc itself. Typically, the parts made of the zinc alloy: die casting, toys, ornaments, welding equipment, carburetor, fuel pump bodies, instrument panels, wet-dry battery, fuse plugs, pipe, organ pipes, munitions, cooking utensils, and flux. Other forms of zinc can include zinc oxide, zinc sulfide, widely used in paint, rubber, and zinc dust when used in manufacture of explosive and chemical agents. Capabilities: zinc can be cast, cold worked, extruded, machined, and welded. Limitations: do not use zinc for die casting with continuous contact with steam. Properties: zinc has a tensile strength of 1,200 psi and 27,000 psi rolled. Specific gravity 7.1 and a melting point of 790 degrees Fahrenheit. Is corrosion resistant. Is brittle at 220 degrees Fahrenheit. Appearance: both zinc and zinc alloys are blue-white in color when polished and oxidizing gray. Fracture test: zinc fractures appears somewhat granular. Spark test: zinc and zinc alloys give off no sparks in the spark. Zinc die castings. Alright, your appearance test: die casting is usually alloy zinc with an aluminum, magnesium, lead, tin. Lightweight, general silver is white in color like aluminum. Sometimes the intricate design. A die cast surface is much smoother than those casting made in sand, almost as smooth as the machine surface. And sometimes the die casting darkened used may mistaken malleable iron when judged simply by looks. The die casting is lighter than weight of sulfur, lighter in weight and softer. Fracture test: the surface of the zinc of the die casting is white and slight granular structure. Spark test: zinc die casting gives off no sparks. Torch test: the zinc dies casting recognized by their low melting temperature. The melting boils heat with the oxyacetylene flame, and the die casting after the cleaning can be welded with the carbonizing flare as a tin and aluminum solder filler metal. If necessary, the die cast parts can be used in the powder to make a new brass casting. Alright, white metal die casting. In general, these usually made with the alloys aluminum, lead, magnesium, except for those made with lead and tin, are generally light in weight and white in color. Appearance of surface is much smoother than produced by the casting made in sand. Fracture test, fracture surface white and somewhat granular. Spark test, no sparks given off of the spark test. Torch test, melting points are low and metal boils under the torch. Section 2, standard metal designations, and that was part of, so we'll come back and do part 7, chapter 7, section 2.